All right, guys, so I'm going to be going over the review for our last unit here, the linear patterns review. So you can find that link here on our classwork page. It's a Desmos activity. So once you click the link, you're going to be brought into Desmos and that will load up. You want to make sure your name is in there because you are going to get credit for doing the review, and then go ahead and click go. We'll be working on this together in class, but this is for you to watch later on if you missed it or you need to kind of catch up. So here's a warm-up. We're going to find the rate of change in each table. And I want you to make sure to draw on these tables to show your work. That's going to be especially important on the test to show me what your thinking is. So remember, rate of change is the change in y divided by the change in x. So we want to look and see how the y values are changing. They're going from 5 to 7 to 9 to 11 to 13. That looks like it's constantly increasing by 2. That's our change in y. And then our change in x is 0, 1, 2, 3, 4. That's just an increase of 1. So when we write our rate of change or our slope, it's the change in y on top, which is positive 2, divided by the change in x, which is 1. And obviously that simplifies. 2 divided by 1 is 2. So that is our rate of change there for the first one. So m equals 2. You don't have to write m equals. You could say it's the rate of change. That's just the symbols that we use for that. Do the same thing over here. We have a few tables, so I'm just going to quickly go through those. Change in y. Pause it if you want to try this one on your own. 22, 16, 10, 4. We're decreasing. This is a negative rate of change here. Looks like it's going down by 6. Remember, you can always sort of figure out the difference between these numbers just by subtracting them. So if you do 22 minus 16, that's going to give you a difference of 6. And we know that it's going down. So there we go. We get a decrease of 6. So that's our change in y, and then our change in x. It's always important to check that. Sometimes it's 1, sometimes it's not. In this case, it's 2. So here our rate of change is negative 6 over positive 2. Change in y on top, change in x on the bottom, which is negative 3. So there we go. That's our rate of change in the second table here. Sorry, this is a little confusing. And then the third one, I'll scroll all the way down, and I'll do this one in green. So our change in y, 1, 6, 11, 16. It's going up. It's a positive rate of change. We're increasing by 5. And then here, negative 3, 0, 3, 6. Our change in x is an increase of 3. So our rate of change is 5 over 3. In this case, doesn't simplify. That is simply the answer. We have to leave it in a fraction form. So here m equals, and we can put it in as a fraction using our input tool here, and I'll put in the fraction button, 5 over 3. And there we go. We can share these answers with the class, and there we go. Move forward. Next, move on to the other things we learned in this chapter, in this unit. So we have these patterns of figures, and I want to talk about how those things are increasing, decreasing, how they're changing. So one thing that's useful here might be to make a table. So we could have our pattern number and then the number of blocks. So for pattern 1, pattern 2, pattern 3, we have 1, 2, 3, 4 blocks in pattern 1, 1, 2, 3, 4, 5, 6, 7 in here, and then 3, 4, 5, 6, 7, 8, 9, 10 in that one. This gives us a nice way to look at this. So we can see how the numbers are changing. It looks like we're increasing by 3 blocks as we increase the pattern number, right? We go from 4 to 7. That's increasing by 3. And then the same thing here. We're increasing by 3 again. So our growth pattern in this case, growth pattern is another way that we said rate of change in the beginning of this unit. So our growth pattern here is plus 3 blocks. per figure, or per pattern rather, sorry, per pattern. Again, that's the way we want to kind of write that. We're really descriptive using words instead of just symbols here. So we are increasing by 3 blocks per pattern. How many squares will be in the next figure, in figure 4 or pattern 4? If we increase by 3 one more time, right, that would give us 13 squares or blocks. I'm going to call them blocks because that's the language I was using, but there we go. And we can click submit there. Next. All right, here we have a little bit of a word problem that can be answered using a table or other thinking. Kind of, we'll go through both ideas. So let's read it and make sure we make note of the important information here. Lily wanted to save money so that she could buy a set of AirPods. She currently has $70, so that's how much she's starting with. And it's important for us to kind of make note of. So I'm gonna write some things down. You may want to do these things on our paper. So she starts with $70, okay? She plans on saving $12 per week. So $12 per week. That's how much she's going to save additional to what she has in the beginning. How many weeks until she has a total of $130 she needs to buy the AirPods? Okay, so her goal is going to be $130. That's what she's trying to get to. So in this pattern, we can go a few different ways with this. One way would be to create a table. You can say, all right, she's starting with 70. We always, at the beginning, that's like when our time is 0. So in this case, week 0, she has $70. And then she's going to be increasing by 12 each week. So after 1 week, she's going to have 12 more dollars. So we add 12 to that, we get 82. And then we add 12 the next week. She saved another $12 and we'd be up to 94. And then we add another $12. So she's at 106 and so on until hopefully we reach the goal here, right? This is one way to do this problem. And I'll kind of keep going with that until we get to that. So increasing by 12 more, that would be $118. Increasing by 12 more, that's $130. And now we've reached the goal, right? We could keep going with this table, but there's no need. We went ahead and reached it. We have our $130, so we can answer our question. After the 5th week, after 5 weeks of saving money, that's our answer, right? So 5 weeks. There we go. And that's our answer. That's silly, the name is wrong. I think maybe someone edited this, should be Lily. How many weeks will it take for Lily to save the $60 she needs? Took 5 weeks. Submit. That's an interesting question though. It said $60, but remember our goal here was $130. That's because $60 is the difference here between what she started with, $70, and her ending goal there of $130. So important to notice that. Right, let me clear this, kind of keep going forward. Next one. All right, so the 2 points given are part of a linear relationship. What is the slope between those? So remember, slope is another way for us to say rate of change. So slope is another way for us to say rate of change, and that is always change in y divided by change in x. Sometimes this division will simplify to be a whole number. Sometimes it will remain a fraction. We kind of have to see what happens here in this problem. So we take our 2 points, 2, 13, x, y, and 4, 5, and we make a table. And then we need to figure out what our change in x and what our change in y is here. So going from 13 to 5, that's decreasing. We could count it out here, or we could figure out the difference, whatever we want to do. But this is decreasing by 8. That's our change in y. And our change in x, we're going from 2 to 4. That's an increase of 2. So when we go to write this slope, we want to write it as change in y on top divided by change in x on the bottom. So -8 positive 2. This simplifies. This actually divides out evenly. If we divide this, we should end up getting negative 4. Now, when you are typing your answers out on a test, you do need to actually show me a little bit of a process here. So slope equals, and I'm gonna put in an equation so that I can make this fraction. So negative 8 over 2, and that equaled negative 4. That shows me that I knew that I was doing change in y over change in x and that I simplified it. I need to see that work from you guys. Click submit. There we go. And let's go ahead and move forward to the next problem. All right, here we go. So in this problem, we are going to answer the following questions to help write the equation of this table. So we're going to be writing an equation, a linear equation. A little reminder of that, y equals mx plus b. M is the rate of change or slope. B is the starting value. So two things we're going to find out. Doesn't really matter the order that we do it in. We'll just kind of follow the way the problem does it. All right, what is the starting value? So remember, the starting value is the y value when x is 0. If x equals 0 is in the table, this problem is very easy. And it is. It's right here. X equals 0 is in our table. The y value is 6. So there we go. This is our starting value is 6. Again, I can kind of circle that, but there we go. And that's our starting value. The next thing we need to know is rate of change. That is our m. So for rate of change, we've been doing this a couple times, but change in y over change in x. So we got to look at our table and figure that out. Our change in y here, we're going 4, 6, 8, 10, 12. That's counting by 2s. That's increasing by 2 each time. And then our change in x, negative 3, 0, 3. That's increasing by 3, right? So for our slope, remember, change in y over change in x, or rate of change, however we want to say that, slope or rate of change, it's going to be 2 over 3. Change in y over change in x. This is one that has to stay as a fraction. So we'll go ahead and leave it that way. There's no way to simplify that. We could get a decimal, but we prefer it in a fraction if it doesn't divide evenly here. So that's our answer. Yeah, it even gave us the decimal version. But again, if it's a decimal, we prefer that fraction. That would help us graph it in the future, and that's a little more useful. Now, equation. We need to put those two things into our equation. Y equals mx plus b. M is the rate of change or slope. B is the starting value. So when I write this, I'm going to go ahead and make it an equation. So I'm going to do y equals m. M is our slope, or our rate of change, which we just said was 2 over 3 x, mx, rate of change times x, and plus b, the starting value. And that we just figured out earlier was 6. So that is the equation here. Make sure to use that equation editor when you type it in, especially if you need to put a fraction in there. Makes it look a lot nicer. You could do it without, but it's going to make it look nicer. And then we can submit that and move forward. All right, only a few more here to go. Let me clear this off. A few more important skills. Here we go. We have a linear relationship in this table, and we are going to answer these questions. Draw on the table to show your work. The rate of change is, remember, rate of change is change in y over change in x. So we can look here at how the y's are changing. They're going down. The numbers are getting smaller. 20, 16, 12, 8. They're going down by 4. And then the x's here are going up. They're going up by 2. So rate of change, remember sometimes we call that m, negative 4 over 2. That divides nicely. If we do the division on that, we actually end up getting just negative 2 as a whole number. Important to do that if we can. Yeah, it's an important part here. Now let me actually clear that stuff off, because I'm going to need to do one more important thing with this table. All right, so our slope was I'm going to show the whole process. We got -4/2, and we said that simplified to just be -2. So our overall answer there, that kind of shows the work that I could have also kept written on the table. The next one is the starting value. So on the last page, we mentioned how the starting value is when x equals 0, it's the y value. But when I look through this table, 2, 4, 6, I don't see 0 here. 0, if we think about this pattern, would come right before this 2. So 0 would be right here. I'm actually going to do this in red. So 0 would be right here. Because if we count up by 2 from 0, plus 2 is 2. So that's the number that would come right before this. We need to also figure out the y value. What would come right before 20? We can kind of continue this pattern backwards is one way to think about it. So if we're decreasing by 4 to go down our table, we're also increasing by 4 to go up our table. That's the opposite here. So the number that would go here is 24. And you want to check it, make sure that does work. 24 minus 4 is 20. That's our starting value. So B equals 24. And we showed the work there on the table, so I don't need to write anything else out here. Now, if we were wanting to write this as an equation, remember y equals mx plus b. M is the rate of change, so -2x, plus b. B is the starting value there that we just found out. That would be the equation. This problem didn't ask for it, but we could have come up with it because we had all the information necessary there. Okay. Let me go ahead and move forward and see what else we have. Constructing arguments. So any of these constructing arguments questions, it is very important for us to explain in a full sentence or two what our answer is. Explain how to find the rate of change of the table to the right. You can say what the rate of change is, but you must write in words. So what we're saying here is just calculating rate of change, just figuring out change and y or change, just doing the process is not enough. You need to actually write in a sentence what you're doing. So let's go ahead and go through what we need to do. Remember, rate of change is change in y over change in x. So we look at the table and find the change in y. We find the change in x, and we write that out as a fraction. Change in y, we're increasing by 2, 4, 6, 8, 10, 12. This one's a little trickier. This is one of these situations where it might be difficult to go between the first two numbers. We are increasing. We're going from negatives into the positives, so we are going up. It might make it easier to look down your table a little bit here and look at maybe numbers like these, like going from 4 to 9. It's easier to see that that's +5. Some people have a hard time seeing it in the negative, so you can always look farther down your table and see if you can figure out the change in the values there. All right, we need to write out this sentence. So rate of change is equal to the change in y divided by the change in x. So we must look at the table to find the change in y and change in x. Then write out the rate of change as a fraction. There we go. And we can even show this. So m equals change in y is 2 over change in x is 5. That doesn't divide evenly. We'd get a decimal here. We can go ahead and leave it. We could even show a little bit more here if we wanted to. We could even show this if we make a fraction here. Change in y, change in x. We could even kind of write it out that way, just showing what numbers are going there in that fraction. Submit my answer and move on. Okay. Important thing with Desmos, your answers are saved. You can always go back and change those if you need to. So I can go back to any of these slides at any point and change them if I need to. All right, last question, critiquing the reasoning of others. So with these problems, it's very important for us to remember there is a mistake somewhere. Honestly, the way I like to think about them is solving the problem on my own first, and then after I've solved it, figuring out what's different with my solution compared to the answer that's given. So Johnny was asked to find the slope. So slope is rate of change. It's not a graph. This is actually a table. So find the slope of this table. So we look at it, 6, 9, 12, 15. That's increasing by 3. 0, 4, 8, 12. That's increasing by 4. Okay, so rate of change is 3 over 4. Change in y over change in x. Okay, now let's compare that to what Johnny has said. Okay, since the change in x is 4, okay, I agree with that. Go ahead and check mark that. Change in y is 3, okay, I agree with that. Then the slope of this line is 4 over 3. Different. I got a different answer. So they identified correctly the change in y and the change in x, but they wrote it wrong. So what is the error? Let's go ahead and identify what the error is. They wrote change in x over change in y, which is not how you write the slope. What should he do? Okay, the slope should be 4 over 3. I could leave it that way, but I'm going to add just a little more, just further explanation, so that I'm sure that the person grading this knows that I understand what's going on. Okay, so the slope should be 4 over 3 because the slope should be written with the change in y on top and the change in x on bottom. Again, thoroughly, so that I really know what's going on here, using our words to explain. And that's it. Those are kind of all the major skills that are going to be on this assessment for you guys. So good luck. Go back, rewind this video, try to find a question that's similar to one if you're kind of using this to help you finish. And yeah, good luck. See you guys next semester.